Hello, my name is Bernd Dippold. I'm responsible for the IMC telemetry systems and would like to welcome you to our today's webinar about telemetry systems. I'm now 7 years with IMC, starting as a salesperson, and since last year I'm working for the business development department. In that circumstance, we have more than 20 employees located in the Munich area working in our telemetry team, and worldwide more than 3,000 systems installed. If you have a look on our customers, there are a wide variety from automotive coming to aerospace industry and railway industry, and that is what we are looking today into. But first, let's start with a bit of historical background of IMC. Founded 1988 in Berlin with the idea of selling test benches for loadless testing of electrical motors. So the picture on the right hand shows you the IMC facility, and the cars you see they are in the beginning of the last century. These are electrified cars, and the difficulties in that time as well as today, the power consumption or the battery capacity was not big enough for a good driving. So today IMC is developing and producing hardware and software for measurement data acquisition systems and for the analysis of the measurement data. We worldwide supply solutions for time synchronous acquisition of multi-signal applications. And we are happy that our customers get everything from the measurement device to the finished test bench solutions all out of one hand. Since 21, IMC is part of our Axiometrics Solutions Group. Let's start with the telemetry system. Which kind of application do we serve with that system? Of course, it's our main customers are coming out of the automotive market, wind energy market, ship, train, and energy. If we have a look on the telemetry specific point, we have a rotating side, which is not connected to the stationary side. And on the rotating side, the sensors are very wide variety we can use. This is voltage, we can measure current, temperature, strain gauge, IEPE, which means vibration sensors as well. The sensor information is collected and digitized and digitally transmitted to the receiver system on the stationary side then. And from the receiver system, we can go with an analog output out if that is requested, but we can use the CAN bus more typically and the Ethernet connection to one of our data acquisition systems to collect the data and mix them up with a time synchronous information from a wide variety of other sensors which are on the stationary side. So the measurement system we use is coming from our house itself. It's a Kronos Flex system, for example, which is a capable system, which is very flexible, extendable, and has a measurement capability of sample rate of up to 2 megahertz overall, and a wide variety of different amplifiers which can be connected to the main system to serve all kinds of sensors in that field. If we would like to add some field bus information as well, we can use, for example, the bus stack flex of our company, which serves the CAN bus information or FlexRay or LIN bus information, which is very common in the automotive industry, but as well AirLink from the aerospace industry or MVB protocol from the railway industry. And for low speed measurements, we can enhance the system as well with the Kansas Flex and Kansas Fit software, which helps to provide low speed data to the complete system. The system configuration, the visualization of the measurement data, and the further processing of the measurement data is done by IMC Studio, our integrated software for the testing process, and the data analysis is done with IMC Farmers, which is seamless integrated into the complete world of the IMC measurement family. Telemetry. Where does it come from? Some historical background. What does it mean? Telemetry means that some measurement data are recorded on an on-site recording and transmitting from a remote point to a local point on the receiving station. Where does the name come from? It's a derivation from a Greek word tele, which means remote, and metron, which means measure. Even James Watt used, together with his steam turbine, a telemetry system, which was a steel tube, a long steel tube, and a mercury pressure gauge, just to measure the pressure of his steam turbine from a longer distance, so he is safe in the field if something happens. And more common, it came up in the late 1920 years of the last century. The telemetry systems were used in weather balloons who record altitude and temperature and humidity and transmit the data from the weather balloon down to the ground station. The common usage of telemetry today is the meaning that the measured data are transmitted wireless to a receiving station. And this can be analog or even digital signals. When we talk about telemetry, we divide it in two different fields. The first field, wide field telemetry, means that the digitized data are transmitted through a bigger distance. This can be a couple of 100 meters or going up to several kilometers. And it is very typically used in flight test applications. As you can see from one of our customers in Switzerland, where we have a couple of thousand channels installed inside of the airplane, and the measurement data are taken during flight and transmitted to ground station to be recorded and evaluated even during the flight test. More common and more often used in the industrial field is the so-called near-field telemetry, which means that the distance of the transmitted data are only a couple of millimeters, 10, 50 millimeters, maybe going up to 100 meters, but more in the 50 millimeter area. And the difference between all the systems available on the market is the kind how the data are transmitted, inductive, analog, or digital, radio transmission. The number of channel varies, and the data transmission rate and the analog bandwidth of the channel varies. And in the picture on the right hand, you can see a milling machine, which is equipped with two triple axis force sensors to measure the cutting force of the knives. And they are transmitted through the coils, which you can see on the upper level of the round plate, to the data head and the power head to record it on the stationary and take some shut-off procedures if the cutting force is getting too big. Are there some alternatives to telemetry transmission of the measurement data? Yes, there are. There are some cost-effective alternatives like slip rings, but there are some wears and tears who can cause measurement errors, and that is not what is typically the way customer would like to get the measurement data recorded. So the digital telemetry solution from IMC is done for a wide variety of different applications. And we can start here with the distance between transmitter and receiver. Is it a couple of millimeters at 10, 20 meters and more? That is required to make a proper proposal for the customer. Next point is the transmission frequency. It varies all over the world. The 2.4 gigahertz Wi-Fi frequency is very common all over the world, but all other frequencies are varying depending on the area where the measurement are located. These frequencies are only relevant if the transmission distance is bigger than a couple of millimeters. So if we talk about 10, 20, 50 meters, it is important to select the proper frequency for the transmission rate. And as you can see, we can serve more or less all available frequencies all over the world. Next information we need from our customer, which sample rate per channel is required. So we can go from 1 kilohertz for low speed measurement up to 50 or 60 kilohertz for high speed measurements. How many measurement channels are measured, recorded? Is it going from 1 channel up to 256 channels? What we can do here. How the signal should be processed is an important point. Just measured and recorded, or is there some conversions to engineering units required, or further online calculations and monitoring, like getting power out from the measured current and voltage, from measured voltage and current? Do we have to have a look on some limit values which are set in that field? What are the dimensions of the machine and the plant are important information for a proper proposal. Which mounting dimensions do we have? What weight can be brought to the machine additional? And we often ask for the shaft diameter, and the customer is answering, oh, it's large or it's small. And if I'm talking about large and small, everyone now has a dimension in his head, what he thinks, what is large, what is small. But some customers tell this as a small shaft, and it is a huge shaft for me, from my point of view. So we need machine drawings or good sketches to get ideas of the application and to make a proper solution to the customer. Next point is, what is the maximum speed of the machine? If we talk about more than 6,000 RPM, we have to pay attention on the balancing of the telemetry system, and of course personal safety always has to be observed. Nevertheless, to get into a first discussion with the customer, there is a telemetry request form available which helps the customer to feed us with all the information we need to make a proper proposal. So as spoken before, we select XY direction, number of channels and measurement speeds, and we can serve all of these parts with one of our telemetry systems. Starting with the very low one, with the single channel version, which is just a small box, which can be installed inside of a supporting ring and running. And that can look like this one here. If you can see the rotating axis, and you can see the supporting ring here, and inside of the supporting ring we have mounted the telemetry system here, and outside the coils for power in and data out are winded through the support ring. So that is a very easy installation, and it can be very much predefined and help the customer to make it easy and the handling quick to him. Which kind of sensors we can use with that system? We can use strain gauge sensors, PD100 temperature measurement, or thermocouple tab K. Sample rate is something above 6 kilohertz, and analog bandwidth is more than 1 kilohertz. So it fits more or less to the most mechanical applications we need here. 16-bit resolution is very good, very big. We have auto zero functionality, and we have an inductive power and data transfer into the system and out of the system. So the overall installation is, you see the support ring with the coils and the telemetry system inside, and you can see on the lower hand the data and power head, and the receiver electronics, which is on the stationary side. So from the application point of view, the small telemetry system even can fit to very big applications. And if we cannot work with some support rings or mounting possibilities, we even can use a single channel flexible PCB board for the telemetry data transmission. Coming to the next system, which is a 24-channel maximum system for medium measurement speeds. We have 4 of that transmitter which can be equipped to one complete system together. There are 2 versions available in different temperature ranges up to 85 or 125 degrees C. We have solder pins or screw pins input, and we have different varieties of frequencies here, 2 different transmission frequencies available for that system here. We have a big variety of different sensors we can connect to our transmitters, which are first thermocouples with single-ended or differential output. We can use from quarter bridge up to full bridge strain gauge sensors, all kind of measurement systems. We can measure voltage as well as speed and encoder input. And the configuration is done easily by a web server-based software. So how does power come into the rotating system? First, we can use that so-called ring stator for our transmitters, which gives a lot of flexibility if the rotating axis is not only rotating, but also moving in the X and Y direction. So it's very helpful if the axis is not really very stable. Very often in vehicle dynamics, the axes are not really stable because the vehicle is driving and moving in that part. If that is not the point, we can use an easier installation with a fixed stator, which is just the inductive stator and the coil on the rotating side. And if the measurement time is not that big, if we talk only about a couple of hours measuring time, we can use rechargeable batteries as well as a power supply to our telemetry system. The next one, the compact multi-channel system MTP-NT, contains of individual modules which have 2 channels or 4 channels and can be cascaded to up to 256 channels overall. The sample rate per channel is more than 60 kilohertz, and the analog bandwidth is more than 10 kilohertz. So we are really keen to measure even high-speed signals proper. 18-bit resolution, inductive power supply and data transmission, Ethernet output, these are all possible options for that system, and it can be fully configurable through the software we supply together with the system. So what you get with the system, you have the module support ring, which contains then the individual transmitter modules. We have one power head, we have one data head. The power head is for the power input to the rotating system. The data head is receiving the transmitted measurement data. We have an inductive power generator, and we have an inductive receiver and decoder board, which provides then the output signal we have. So some kind of installation here. We see the support ring, which is integrated to the, which puts the measurement transmitters inside, or they are installed like here in that part here, just with wall mounting. If the situation is bigger, you can use a kind of wall mount, and you can balance that by putting it smooth around the tube where it is installed. And you can select different modules for strain or even for IEPE vibration sensors used here in the system. And last not least, the modular system CTP contains all in one pot, which means we have a round housing which contains everything inside from 8 to 64 channels. Signal bandwidth 24 kilohertz, even pretty fast. 16-bit resolution, very good. And a wide variety of sensors, which are very typically for avionics industry or helicopter testing. Of course, strain gauge and different temperature sensors, vibration sensors, IEPE is integrated as well, and LVDTs and RVDTs, which are used for distance measurement or angle measurement on systems. And these two sensors are very common in the aerospace industry. And the complete system, of course, it is installed outside, is very robust and water resistant. So if we have a look inside of that system, we can open it and the customer can change the telemetry modules by himself. So if he has sometimes only strain measurements, he just uses strain gauge modules, and if he would like to switch to temperature or IEPE sensors, he can do that by himself. So he can condition the system in a matter he would like to have it. Yeah, coming to a kind of application now. This is a gearbox application. This is a gearbox application, a gearbox test stand for endurance testing of gearboxes. And the customer, the Technical University of Munich, would like to record the torque on the shaft because too high torque makes the teeth breaking and scratches on the teeth, which is not really helpful in that field. And you can see the support ring installed on the axis and the power and data head installed on the axis. And the customer likes that system very much because it is easy installed. He changes his configuration regularly. He has something of maybe 50 different test benches in that field. So he's changing his configuration very regularly. And it helps him very much that the installation of such a system did not take more than 1 or 1.5 hours to be prepared for the next testing. Coming to a big size, bigger one, even gearbox testing, but now on a wind turbine gearbox, which is much bigger. We have much more channels. The other one just had a one-channel solution. Here we have something of more than 30 channels installed here. And we measure the stress, the strain on the teeth of the gearbox and continuously record that. The extraordinary thing in that application is you can see the modules installed on the rotating axis. It is closed, that system, and the complete system is running under oil. So we measure our systems are oil-proofed installed, and we continuously measure inside of the gearbox oil area. This is also a wind turbine application. This is a single channel application. We still use our T1 system with one channel strain gauge measurement. But it is very easy to install in the wind turbine because everything is prepared on the ground. We have that special mounting flanges left and right side. We have the strain gauges installed on the flange. We can calibrate that flange to get a proper torque measurement system. And the installation from the strain gauge to the telemetry system is also done very easily with the composite material housing, which is used also as a safety possibility for the strain gauges and the sealing for the strain gauges. The telemetry system is seen outside on the picture here, and you can see the coil winding for the power input and the data output of the system. This is a bigger one. We have here a cement grinder. It's also only a single channel measurement. We use still our T1 telemetry system here. It's also a strain measurement, and the strain gauges are sticked onto the driving shaft of that cement grinder, and the diameter of that shaft is something of 1.6 meter. So it's a really big one, and we provided the customer with a mounting ring, composite fiber mounting ring, which covers the telemetry system inside and helps for a quick installation and a very robust installation, long-lasting installation to the customer. It's a continuously monitoring of the drive shaft, and it's very useful for harsh environmental conditions, and it works long years in that area. The next application is railway bogie monitoring. As you can see from the customer logos we used on top, that is a very common measurement for us. So we install the telemetry system in a daisy chain version on the wheel. We take the data, which is different kind of sensors, from force sensors, strain measurement, bending measurements, and torque measurements, and of course also the temperature of some brake information or of the bogie itself are recorded here. So it can be scaled from couple of channels up to 10, 20, 50 channels, and it can be easily adapted by just changing the modules. If you like to have more vibration measurements, just change the modules to the vibration modules, and you can enhance your measurement easily in that field. Typical application, as well seen with the customer logos on top, very often used, are helicopter measurements. We use the CTP system described before with the round housing, which contains everything from the telemetry modules inside, the batteries inside. And in that picture, the installation was done on top of the helicopter rotor. It's a hassle-free installation of a lot of sensors. We did it with 62, 64, 32 channels, and a wide variety of different sensors which are measured here. The first test was on top of the rotor, as mentioned before. It worked very well for the customer, and we got in the second step in that application. So the customer tried to install a parachute on his helicopter. It's a lightweight helicopter. It's no big one, but it's a lightweight helicopter. And he said, okay, we would like to enhance the safety of the helicopter by installing a parachute on top of it. So we have to change the location from the head of the rotor to the drivetrain underneath of the rotor. And that happened with our dual channel modules, which are installed beneath the rotor. So you see on top the parachute container of the rotor, and in the bigger picture underneath, this is the installation, also like shown here on the round tube here, with our telemetry systems around. Next point is a hydro turbine measurement, which is installed in Austria, or a couple of other customers use the same system here. It's done with our MTP-NT system, because we have a modular system with a lot of different channel input possibilities. And the very sophisticated point on that installation is that the measurements were done on the blade of the water turbine, but the digitized data were put through a 50-meter long cable from the turbine wheel through a hollow shaft to the generator, and in that station it was transmitted then wireless to the receiver station. This is another example which also is possible to be done. It's a flywheel mass dynamometer installed here in Germany at a customer. Even very quick installation, because of course we have very often changing measurement conditions from different channels and different sensor signals. Temperature, of course, is always a point, but strain as well. And it is installed with the support ring here, direct on the test rig for endurance testing of brake disc measurements. And last not least, even a bigger one here installed, an ocean-going tugboat, which is moving the oil platforms over the ocean, and they would like to monitor the force which is set to the winch, and it should be stable, or it should be not come above a certain level, and all tugboats which are carrying the oil platform should move with the same force, and that is done with a single channel installation. And the good point for that customer is that the change of the measurement system or change of the winches, the new installation of the telemetry system only takes an hour, and the thing can go on as well. Last not least, another very sophisticated application here is some pass-by noise application, which means that you record different levels of voltage, the engine speed and the vehicle speed, and the pedal information like acceleration of the pedal and the pedal standing here. And that transmission is done through 2 kilometers, which was possible by pointing out a couple of antennas along the way of the installation. And we did that measurement to a couple of German automotive customers, and it's very helpful to do these measurements. Yeah, that's all out of the webinar for today. I hope that the information was very helpful for you. In case you have any questions left here, you can use the chat function to send it to us. We will answer it later on, or just drop an email to me and I can pay attention on your question and answer it immediately later. Thanks a lot for your attention, and have a nice day. Thank you. Goodbye.